Thank you for being here. Just to repeat myself for those who've just joined, this is the MIT Alumni Golfers Association webinar on the biomechanics of the golf swing, where MIT alumnus Ben Taylor will be telling us about his research and his thoughts in this domain. I'm Tony Davis, president of MITAGA, MIT Alumni Golfers Association, and I thought I'd just before we get into today's proceedings and tell you about the format of today, just let you, for those that don't know about MITAGA, we are obviously an alumni group of MIT. There are about 400 members. The things that we do or offer, well, once you're a member, there's a bespoke or customized directory of everybody in this group, in this interest group. So if you're looking for golfers to talk to, play with in your area, or if you're on the road traveling, that's a resource to find like-minded alumni who enjoy golf. We have a couple of tournaments a year, virtual and in person. And then apropos of today, we conduct a handful of bespoke webinars during the course of the year. We've been actually very lucky to have a fairly prestigious and varied group speaking to us. We've had golf course designers and architects such as Tom Doak and Cynthia Dye, just to give a sort of range, Mark Brody of the strokes gained methodology. We've had the curator of the R&A Museum in Scotland come and speak to us about the history of golf. Kim Din, who is on our board and MIT alumni, played in the 2024 US Women's Open and gave us behind the scenes what's it like to be there and see the stars and tee off on a very nerve-wracking, no doubt, first tee. We've had the co-founder and CEO of Five Iron, which is an indoor offering using the TrackMan technology. So quite a sort of varied group of people speaking. And later this year, another MIT alumni will be speaking who's a senior engineer at Callaway Golf. And then we also later in the year have someone who spent many years as a senior manager, part of the senior management team on the PGA Tour, and he's now CEO and president of the Annika Foundation, so Annika Sorenstam Foundation. So he'll be talking about both his insights from both those experiences. So that's just a bit about MITAGA. Today we're running for an hour, depending on your time zone, through until 1 p.m. Eastern time. And we will have a presentation for probably 35, 40 minutes from Ben. Going to be very interesting. It's built on his thesis. We'll hear some of the analysis and outputs that came from that. He's also profiled the swings of various professional golfers that have either classic or slightly different swings, and some of them over time, how have they changed? So that'll be interesting. And then a little bit looking into the tools and apps in the swing domain, if you will, and where we see or where Ben sees some of that story going. So that'll be very interesting. It's a presentation where you won't be able to come off mute. You can write questions at any time you want in the Q&A box. So the Q&A box at presumably at the bottom of your screen, but not chat, but the Q&A function. Okay, and we'll finish the presentation and then come and address the Q&A. You can also, of course, write it during the Q&A portion. So in essence, 35, 40 minutes from Ben with the presentation, and then around 15 minutes of Q&A driven through the Q&A space within the Zoom webinar. So that's the story for today. Again, I thank you all for joining. And then just very briefly on Ben, but I'll let him talk sort of more about himself and more relevant to today's topic. So as I said, he's an MIT alumni, did his master's in engineering and management. And this thesis, and this is recent, 2025, I think. So this is from his current thesis. He had a career in the Navy and is now a senior principal systems engineer at Raytheon. And I'm assuming earlier on was when he did a master's and a bachelor's at Duke University, also in engineering subjects. So rather than say any more, it's my pleasure to hand over to Ben. And thank you very much from MITAGA and all the alumni for agreeing and doing this wonderful webinar today. So thank you, Ben.
Thank you very much, Tony. Thank you for the opportunity and the great introduction. I'll start off by pulling up my slides. Let me know when if someone could give me a confirmation that they're up.
Yep, you're good with Tiger Woods on the left.
Yep. All right. So since Tony provided the introduction, I'll just jump right to slide 3. So I'm very excited to present all this to you guys, and but in preparing for this, I did fight the challenge of trying to consolidate how much information I could squeeze into 40 minutes. So I'll ask for your grace on that. I am from the Boston area, New England, so I stereotypically do talk fast. There will be some slides I go over where I'll just be kind of just a brief overview, but by all means, if there's any slide that catches your eye and you'd like to go into more detail, please post that in the question chat and we can go back and address any of your interests later on. And in addition to that, I posted a QR code here on the right as well as the thesis link. Thesis is much more thorough and it goes into things like data analytics across all of golf, not just biomechanics. It also gives credit to kind of the founders of biomechanics and golf over the last 75 years and the history of how they've built on things with limited technology and had some very innovative thoughts. So I do encourage you to look at that if it interests you. Just to set a baseline, this was really an exploratory thesis. I apologize if any of you will be disappointed that there won't be anything groundbreaking, like hey, this one golden rule will fix everything in my golf swing. That is kind of the utopic thing we all pursue in golf. But this is more, as I show you on the slide with the goals. There are places like Titleist Performance Institute, all the golf manufacturers who have tens of thousands of dollars they pour into specific golf labs with synchronized cameras, 6 degrees of freedom motion for sensing all attributes of the body. And so I was looking at, based off some modern computer vision technology, what could you achieve with a cell phone? And there are benefits to, a cell phone just being, you can bring it on the course. You don't have to have the financial assets to be able to either create or attend one of these high-end studios. So looking at what kind of a return on investment and how equivalent it is to some of the high-tech stuff. And also, the benefit of just being able to you can filter in a YouTube video from any part of history. So something I haven't done yet, but I'd be curious to do is run something like a Ben Hogan video through this and see how his swing stacks up compared to modern golf philosophies. And then in addition to that, just seeing if I could formalize a process for extracting metrics and converting them into kind of biomechanical interpretations and analysis. So one piece of advice for the thesis is always, follow your passion and then, or if that's something that really interests you, and then also really try to refine your scope because it can quickly just explode and you won't ever graduate on time. And so I was fortunate at MIT to take a sports engineering class where we partnered with the National Basketball Association and created some biometric tooling for them, which actually is being rolled out in the form of a last touch kind of detection for when a ball goes out of bounds. It's being rolled out in the summer league this summer, which is pretty exciting to see how we contributed to that. But that kind of got my interest to biomechanics and kind of computer vision of athletes in motion. And in addition to that, partnering with the MIT Sports Lab, I was introduced to Joe Roca, who's the MIT club golf coach and also provides lessons to all the students. And he's also a formal ambassador for Michael Jacobs, who's a annual Golf Digest Top 10 teaching pro. He works with Padraig Harrington, for those of you who are familiar right now, and has helped contribute to his resurgence on the senior tour. And so Joe is very familiar and implements a very heavy dose of looking at what the body does internally and not just what some other instructors do, where it's more TrackMan and output focused. So it was really great to be in touch with him, and he gave me some guiding points to start my thesis. So that being said, I decided to look at biomechanic piece of the golf swing, and for key scope parameters, I only looked at driver swings. This was just because, for when you hit your drive, you're commonly on a flat tee box. It's a full swing. If you're watching someone hit an iron shot in the fairway, the ball might be above or below their feet. They might be taking a 3/4 swing, so there's a lot more variation there. And in addition to that, when they set up golf tournaments, most of the stands are near the green and the tee box, so there's just much more access to swing videos for drivers. In addition, I am left-handed myself, but I only did right-handed golfers just because of the XYZ coordinate plane. I just wanted to simplify things and have everyone on one side of the golf ball so I didn't have to reorient and maybe create error for myself. I did do some early amateur video of myself just to kind of figure out best way to optimize the tool and my calculations. But for the actual thesis, I looked at professional golfers since they offer the most consistent high performance swings with the littlest variation. And then for your awareness, just there was no detection or analysis of the golf club in it. It's strictly confined to the body elements. Modeling a golf club itself is very challenging. Yeah, you can't just treat it as like an extension of the arm, and so this is still an ongoing thing that's being worked in the golf science industry. And also to limit my scope, I didn't look at any body forces. Part of that was just availability of you can have weight plates to detect how your ground forces move within your feet. And so that there wasn't any availability for that during my thesis. So I just strictly looked at the body elements. And then finally, in comparing all swings I looked at, I did normalize swings to a percentage of the swing rather than to make it independent of swing duration. Some people's swings might be 2.5 seconds, some people's might be three, depending on the violence of the swing, the length of the swing, etc. So that just created a nice baseline comparison foundation. So just to give you some baseline, I won't go and I am not the right person to talk about neural networks or computer vision, but just to give you an overview for some of you who are familiar with it, just a brief touch on how we get from point A to B rather than completely black boxing how the data comes out. So I used an open source convolution neural network compared to like a ChatGPT, which is a transformer neural network. Convolution is best used for image detection, looking at bits and pieces at a time to create recognition through lots of deep learning and analysis of millions of videos. And so for the one I used, which is MetTrabs, it did provide probably more than I needed in 31 different data points on the body, including the ones I highlight here. For golf, as I mentioned, you don't necessarily need all of those, but for an exploratory thesis like that, it was useful to have more data than less and try to figure out what I could cut down on rather than missing something. So just for a quick overview of MetTrabs, there's some European academics who came up with this and published it in 2020, 2021 timeframe, building upon a lot of different 2D and 2D 2.5D models. And what's unique about MetTrabs is that it doesn't just give you the relative positioning to the camera lens or in terms of distance or compared to where the pelvis is, but it actually provides metric coordinates in a real physical world perspective, which is very useful. And in addition to that, it provides a truncation element. So you can see on the graphics on the right, the fourth row, even though body parts are outside of the camera frame, it can provide a predictive heat mapping nature to show where those elements would actually be and create the full body image. So all that being said, I was able to extract swing video, and I'll provide you a couple samples. So this is a down the line view of a slow motion swing at a range, and you can see on the left side provides that overlay of the sensing image or sensory data points, and then on the right side having that into a digitized version. And similarly for a face-on view, here's Tiger Woods. And I will think this is a good point to mention. Compared to the high-end labs, there are limitations with this. A single point of view will never be as good as 360 degrees. In addition, while MetTrabs can imitate 6 degrees of freedom with the X, Y, and Z axes, with the X, Y, and Z axes, it doesn't provide roll, pitch, and yaw elements. So you can get great positional data. However, if you're trying to calculate angular velocities, angular accelerations, you can't quite do it as effectively. So there are limitations there. But as I said, sometimes the 75–80% solution is sufficient rather than just getting the full millimeter accuracies of golf swing. So all that being said, primarily my thesis addressed something called the kinematic sequence. I'd initially thought about doing lag in the golf swing, which relates to kind of the angle of the club shaft through impact based on, wrists and such and forearms. But as I mentioned, too hard to track the golf club. So I came across the kinematic sequence, which I thought was also very interesting. So it's pioneered primarily by Phil Cheatham, who was at Titleist Performance Institute and now is at Sparksbox AI and is a PhD in biomechanics. But it basically looks at the proximal distal sequencing of the body rotation being anything closest to the core of your body in any kind of athletic motion will lead velocity, and there will be a cascading kinematic sequence through from your thorax to your shoulders, your arms, your wrists, if you're throwing a ball, swinging a club. And so that was something I looked at. And you can see here on the left, so these are velocities, rotational velocities of the swing. So you can see if everything's starting at zero, on the takeaway of the swing, as the club moves away from the target, the velocities are oriented negative. And then right before impact on this line, everything starts to speed up. And you can see for the pelvis in red, that peaks first for peak velocity, followed by the thorax in green, then the arms in blue. And then for TPI, who can have better detection of club sensors, they show impact of the club at the highest peak, latest peaking, but also highest velocity. So I found this very interesting. So just to give you some data orientation on the collected biomechanical data I received, as you see on the right, we have the camera for a face-on view. The x-axis goes laterally with, towards the target and away from the target. Y would be distance to and from the camera, and then Z being height from the ground up. And so a lot of my analysis to achieve a correlated assessment of rotational dynamics to the kinematic sequence occurs in the red plane over here on the left, the transverse plane. So really looking at XY data from overhead. And so even though you can see the golfer on the right, you're not standing vertical along the Z-axis. There is some offset there where you might have to use some trigonometry. For the purposes of this thesis, I felt it was sufficient enough to just provide that pathfinding feedback by looking strictly at the XY plane. So another limitation of my study was that in using YouTube, in most smartphones, they default to 30 frames per second. So, on a downswing, which takes 2/10 of a second, that's only 6 frames of data. So that can be very choppy, as you can see on the left. And if there's obscured body parts, if you're taking your arms behind your head or rotating, there's elements that create choppiness. So on the left, you can see some swings where raw data, but then on the right, using some filtering, Savitsky-Golay in this particular instance, again, with the X coordinate being towards the target for positive, as you take the swing back here and up towards the peak of the takeaway, and then the downswing, you can see this is much more polished data. So as I mentioned with the transverse plane, looking overhead, again, reorienting you to the x-axis so for this left side graph, the 200 is towards the target, the negative 500 is away from the target. And lighter colors here reflect the early part of the swing versus the later parts. The colors get darker and darker. So what I wanted to highlight here was the way I achieved angular positional data and velocities, where I created line segments for each aspect I was considering of the kinematic sequence. So for shoulders, I had a line between the two shoulder points. For hips, same left and right part of the hips, left and right kneecap. And then differently for the left wrist, it's not reflected in these diagrams, but I took the left wrist point being the lead wrist for right-handers, and I created a segment from there to the central point of the pelvis where everything is anchored in the model. And so that line, just imagine as your wrist moves, it's rotating around your pelvis, and that created what I felt was a sufficient enough data marking point. There were some limitations, which I discussed in my thesis on that for certain golfers and the way they orient their hands, but for the most part, it provided the feedback. So you can see here at the beginning of the swing, everything is oriented with the knees being a little forward of the hips if they're both horizontal, and then the shoulders, you're hanging more over the ball. And then as you rotate through, everything changes orientation. All right, so using that as the anchor of the analysis, this is kind of a primary chart that I will be showing you for the professional golfers. So similar to the kinematic sequence diagram I showed you of velocities earlier, this is strictly a positional angle, so how those angles of the segments change throughout the swing. So you can see using the P classification method on the bottom, for P1 at address, everything I had oriented to 0. And then during the takeaway, all the angles become more negative as they're rotating away from the ball and the target. And then similar in a correlation to the kinematic sequence, even though I'm not measuring peak velocities, showing when parts of the body start to rotate forward or activate the kinematic sequence, I thought would be kind of equally useful. So with these horizontal dashed lines, these mark the local minima points where the body stops turning away in the negative and starts turning forward in the positive. So to reflect the kinematic sequence, ideally you want the gold first for hips, followed by knees, and then in green, and then blue for shoulders, and then red for wrist, which is a proxy for the golf club. So you can see here as they all turn, shoulders turn to about roughly 90 degrees. Left wrist turns greater than 100 since it is oriented, even though I have it starting at 0, it is oriented offset, roughly perpendicular compared to the rest of your core body. And then for impact, that is roughly reflected by all of these points coming back to the 0 point where it's at address. And so for each of those, the shoulder turn occurs somewhere between P3 and P4 as the club approaches. Normally people finish their full shoulder turn, but then their hands peak on the downswing, or sorry, on the takeaway at P4. And then at P7 is where impact is. And so an additional metric I looked at was shin angle. As I mentioned, we didn't have force plates to calculate ground forces, but working with my thesis advisor, we thought this was a pretty creative solution to reflect weight shift during the swing. So you'll see here with Nelly Korda, in the red, I have highlighted what I call shin angle. And so if you use the ground forward of Nelly as 0 and rotate that back, that will reflect where the shin is, the line between the ankle point and the shin itself. And so as you start your swing, that value of the angle will become greater as it's shifting away from 90 degrees. Most people in golf will shift their weight back during the swing, so that'll become up to 105, 110, 120 degrees. And then, especially for professionals, they will activate their weight almost before they finish their takeaway. And at that point where you see a local maximum, that's when the weight's shifting forward. And I thought that would be a useful comparison to fold in to provide further contextual swing analysis. And so as Tony alluded to, give you some of the professional golfers I looked at. On the left side were ones I looked at just for the kinematic feasibility. 17 golfers, I'll highlight 7 of them today for their unique features. On the right side, I used current PGA Tour players to look at biomechanical predictive performance. So I used these ones because over the last 2 years, the PGA provides statistical data, like, for example, shots gained, which was in a previous webinar, good maximum or average driving distance, accuracy. And so I wanted to see through regression modeling, if I look at these players' biomechanical data, is it predictive of how good of a driver they are? And so just to highlight some of these golfers for you, Tiger Woods being, one of the great influencers in golf. As you can see here for his swing, I'm not going, as I mentioned before, I won't go into full depth on each one of these, but I'll just highlight some key points for each one. So for him, you can see he does follow that kinematic activation of yellow, green, blue, and red. Nice smooth curves. And then, as I pointed out, you can see the maximum of his shin. If you look up top, it's not perpendicular straight up. It is tilted backwards in an athletic stance. So it starts at roughly 95 degrees, and then it gets greater as he turns. But then his weight starts shifting forward. You can see in the third picture from the left, he hasn't quite opened his upper body yet or his thorax, but he's starting to shift forward. So this is from lessons and talks I've seen. Um, the biggest discriminator between a professional and amateur golfer is they start their weight shift much earlier than an amateur an amateur, for example, might start their weight shift almost during impact during the downswing itself. So I thought this was a unique validation of that distinguishing feature. Here's Nelly Korda, who has one of the most picturesque swings on any professional tour. So you can see for her, even more clear distinction between yellow, green, blue, and red. However, for her, she does start her weight shift much later than Tiger's. And I think this could be attributed to just her flexibility, where you can see she is quiet from the second picture to the third picture, but she does start activating her hips more, which can generate, more internal tension in the body, more power. So I would attribute that more to her ability her flexible ability, and not just but for a lot of LPGA players, they use that lower body very effectively to create torque. So John Rahm is the next one I want to highlight. For those of you who don't know, he was born with a club foot, so he has very limited ankle flexibility in his right ankle, so that prevents him from completing a traditional shoulder turn. So you can see at his max turn, he is really only about 3/4, as you can see by the blue minimum here for the shoulders, about 75 degrees. Also follows the nice traditional color ordering. But it is pretty neat that he's still one up near the longest drivers on tour, but it shows that you don't need a full backswing. It's really your power is generated by your thorax and your core muscles. So I thought that was very interesting. And then, like Tiger, he does start his weight shift early before the kinematic sequence is activated. So for Bryson, he is a little bit of a variation here. I won't say he doesn't follow the kinematic sequence because I didn't look at the angular velocities, but in terms of activation, I noticed with him as well as sorry, I didn't highlight it, but three of the golfers I looked at professionally were long drive contestants, Kyle Berkshire being one of them. But with Bryson and those three, they do start their shoulders, or they have peak shoulder turn much earlier in the swing. So you'll see yellow and for the hips and green for the knees are stacked here, but the shoulder turn starts much earlier. And you can see here on the right, I think for long drivers, from my amateur perspective, they want to maximize elasticity and the length of their swing. So they're really clearing their shoulders much earlier in the swing to provide that length. And I noticed with him and even Rory, even you'll see his at the peak here, his hands are much farther back. Nelly and Tiger, they're kind of near the right ear. And here, because of that length of the swing, there's almost to get there to create that extra power, but then they kind of reslot, as you can see in the middle picture, back. And so I just thought that was an interesting thing to point out and see reflected in this much more lean prototyping of analysis. So for Jim Furyk, he has one of the most unique swings on tour. I looked at both him and Matt Wolff. And so for Jim, you can see he has very quiet lower body with his knees peaking, pretty much right. There's just very little knee motion rotationally. And then you can see here, if you look at the picture on the right, there's not a lot of activity. He only gets to a little past 50 degrees for his shoulder turn and for his wrists. And if you look at this picture here on the right of the tracing, and you see once he gets to about his hips on the takeaway, he's just bringing the club just straight up. Um, and then he brings it back down, straight down. So there's no rotational analysis to be done there. But then he slots the club and shallows it very aggressively. And then he pins his arm, as you can see in the middle picture, the fourth picture in the middle, and then on the right side, he's pinning his arm. Sorry about that. To the side of his body, and then just does this impressive rotation through. And you can see this drastic slope change of the left wrist. And so there's a great fascinating trade-off here because Furyk was one of the straightest hitters on tour, and so but he was not long. He sacrificed a lot of distance. The farther your hands are away from your body, the more speed and power you can generate just by the torque equations. But he sacrificed that by keeping his arms closer to his body to create more accuracy. And he's the only player on tour with two sub 60 rounds. So it's just interesting how he was, maybe a forerunner of understanding biomechanical analysis, kind of comparative to, for a while on tour, they allowed players to use belly putters where they could anchor it to their belly and just create that extra stability. So I thought that was very fascinating. So quickly to go over Sergio Garcia, I just wanted to highlight, he's always referred to as one of the primary references of lag on the tour. And you can see here on the picture, the right-hand picture, he is really he refers to it as a mental model. He's just pulling a chain straight down. Most people are a little more gradual and gentle in their shallowing of the club, but he's just pulling it straight down. And so you can see right here, there's this local parabola. And so as he finishes his shoulder turn, he kind of cocks the club quickly and then just rips it down. So it creates that very rapid speed change, which I thought was very interesting. And then the final golfer I'll present you with is Michelle Wie. And during her time, she was one of the longest hitters on the LPGA tour. But if you look at her shin angle, she never shifts her weight onto her front foot compared to her contemporaries. And I attribute part of that maybe to she has a wider stance. She did work with David Ledbetter, who was one of the first celebrity teaching instructors on the tours. And you can just see throughout the whole thing, even to the finish, she kind of always has, she maintains that more triangle shape. Perhaps to hit, stack and hit more up on the ball, create more distance. But I did find that an interesting variation. And so here's just a summary of the golfers. This is just showing during the backswing from the top of the swing down, comparative analysis of the colors and where in the swing it occurs for activating the kinematic sequence, not as I'll again hit on, not the velocity aspect, but just when they are activating each piece of the body. So you can see, I guess a key takeaway from the thesis is just there is variation there. I think overall people follow those core philosophies, but each player is kind of like a fingerprint. If you just a quick glance, they all look the same, but there is a lot of uniqueness based on body postures, sizes, ages, limitations. So physical limitations. So for those of you in the crowd who are more business oriented or analytics from Sloan, a piece of my thesis was just looking at that regression modeling I talked about earlier. So these were the second set of golfers, and I looked at more than 6 variables, but these were the ones I settled on for significant factoring in the model of max shoulder velocity or peak shoulder velocity, peak hip velocity, and peak knee, wrist, and shin velocity during the swing. Shin velocity being lateral, whereas the rest were angular. And then as well as X factor. To quickly define X factor, that's early on in golf history, there was a philosophy that you wanted to turn your entire body as far as possible to generate speed. But in a more modern, in the 80s and 90s, there was this emerging philosophy of X factor where you actually want to keep your lower body quieter and create more tension between your hips and your thorax. So you're creating not quite a spring effect, but you're creating elasticity and tension. So the more you turn your shoulders but keep your hips quiet, the more explosive you can be. That was another factor that was looked into my study. And as you can see here, looking at provided PGA metrics of shots gained for drives, average distance, good drive percentage, and accuracy, it does loosely follow some predictive natures. Not quite, for shots gained, I was pretty happy with the R squared. But for the other ones, I think, if I were to run this, it'd be great to run this through all PGA Tour players. There was some variation with the quality of the video I was be able to get for some of these guys. And then at a higher frame rate, it would be even more accurate. So this would be an exciting thing to pursue in the future. So as Tony highlighted, for Tiger Woods, I did find a compilation of annual swing video. They took a driver from each year of his career, drive video from each year of his career. And I thought, hey, this would be kind of fascinating, just see how it stacks up through running it through a biomechanical model. I did find specific videos of his original amateur swing. You can see it as little, there's some noise here. They were, kind of VHS grainy quality. But just from the eye test, you can see, I thought a unique thing was just looking at all these angular rotational assessments of positional displacement. They all roughly look the same. But once I was able to just look at it quantitatively, I was excited to see that the numbers backed up looking at what each of his swing coaches did. So something I think is underappreciated about Tiger is he's I think correct me if I'm wrong if you want in the Q&A, but he's the rare athlete who at his peak was like, I'm going to reinvent myself. Michael Jordan wasn't like, I'm going to change my swing. I'm going to I'm going to change my shot. Wayne Gretzky's like, I'm not going to overhaul my hockey strategy. But Tiger, 3 times successfully completely changed swing coaches, completely reinvented his swing in live. He didn't take years off. And so it's just a validation of how talented he was and probably still is. But so for this exercise, I just looked at, articles on down here of what key swing changes were done under Butch Harmon, Hank Haney, and Sean Foley, and then correlated those with different biochemical analysis indicators. So you can see up here early on for his peak shoulder velocity, as a young pup, he was fast with his swing, and with Butch, he became even faster. But then as he got aged, had spine issues, some surgeries, he did decrease in his rotational speeds. Similarly, he did have a big weight shift earlier on, and then throughout, later on with Butch Harmon, wider stance. With a wider stance, you don't have as much weight shift, shorter backswing, more compact. So that's reflected there. And an interesting piece with X Factor is with Sean Foley. Sean is he's partnered with Sportsbox as a biomechanical tool right now, and he also is a big proponent of TrackMan. So Tiger did increase his X Factor later in his career, probably with his body limitations. That was a way he could still create additional torque and speed to compete on tour without having the same flexibility he did younger in his career. Uh, so for the final piece, I'd like to share, my own thoughts on where things are going with various biomechanical tools and apps. So as I mentioned, for these two on the left, Gears and Titleist Performance Institute provide amazing accurate data. However, you do need all that accessory equipment. For Titleist, this player is swinging with wires, straps on their feet, their waist, and their head, which does provide high fidelity, but we don't all have access to that. I personally don't know if I'd be able to still have an equivalent swing and forget that I held that stuff on me. Gears likewise has all these sensors, but these systems do cost up to $60,000 each. Alternatively, Sportsbox and Swing Catalyst are emerging competitors on the market. They do provide direct-to-consumer apps. You can see here on the left with Sportsbox, it does give you that biomechanical data. With Swing Catalyst, they provide those graphs, which are very interesting. But something I've been fortunate enough just running into the right people is I think there's potential for my thesis to evolve, and I'm currently working with Joe Roca and a couple other guys who I'll introduce later in this brief. But I think the challenge for everyone will be, I think everyone can prove that they can collect the biomechanical data, but the key will be how do you shape it in a way that's useful. I think to go direct to consumer is the wrong approach. I've read feedback for some of these apps where people are like, hey, this is great data, but I don't know how to interpret it. For someone who's an avid golfer, if my instructor or an app were to tell me, hey, your pelvis lift is 3 inches, I don't know how to mentally correlate that into changing my swing or understanding that feedback. And likewise for, I think, a lot of people seeing these graphs, if don't have that technical education background or not familiar with kinematics or Newtonian physics, it's just not the right way to display this information, both to students and then also golf pros. So I think that's where the secret sauce will be, using all this data as an underlying under the hood foundation, but then using either AI or just partnering and supplementing golf coaches to help convert it into something that's useful for the golfer. In addition to just apps, I think there is a great potential for this to be part of broadcasting golf and making it even more interesting to the fans. So I was watching the PGA Championship this year, and surprise to me, I saw this kind of stuff on the screen. I was like, "Hey, that looks very familiar." And so T-Mobile, you can see, I think they created a sensor system around this tee and even going below it to create the three-dimensional analysis. And Trevor Immelman commented that John Rahm has a shorter shoulder turn than the field average, kind of a basic um, analysis piece there. But I think this, as well as for those of you who attended the 5-iron chat, the CEO mentioned he thought biomechanical analysis is kind of the new frontier there. So I think, especially with broadcasts offering streamed, just direct follow this specific group, like the Scheffler Morikawa group or the Spieth Thomas group, in between them walking to each shot, and since they're not just showing you a different group, there is a lot of filler time there where they can use biomechanical analysis to say, hey, this is how Jordan Spieth's last drive went. This is why it failed. Or, hey, he's on the 15th hole. Here's the trends and how his swing is holding up today. So I think there's a lot of potential there as well. So as promised, the project team I'm working with, which I'm really excited, is Joe Roca. As I mentioned, he's at MIT as an instructor, and he might not mention this because he's a humble guy, but he was acknowledged as a New England PGA Teacher of the Year last year. So just a great institutionalized knowledge of the swing theory, and especially through the biomechanical lens. And then two guys, Jerry Liu and Jacob Blindenbach, both on the right side, have created this app called OofSkate, which is doing the same kind of biomechanical analysis for the U.S. figure skating team, also helping NBC with their Olympic broadcast last year. So Jerry was an MIT student. He and I were at the sports lab together, and just overlapping collaboration. He was aware of my thesis, and we talked about, hey, could he use his figure skating tech that he's building and apply it to golf. So this is something we're working on right now, and we're very excited. So for here's just a kind of quick sample of our alpha testing. So you can see it's comparative to what you saw on the previous slide with Swing Catalyst or Sportsbox. Just right now, we're just trying to get a sufficient enough accuracy, running all through the things I said weren't useful for students. But from this point, I can share with you two kind of philosophies that I think would be very useful. So these will be crossover examples, but the first one is just when I was in the Navy, I did have some brief pilot training. And so with a plane, they do teach you, the plane is inherently stable. It has dihedral wings. So if you turn left or right, the plane wants to move back to steady state equilibrium. If you're a good pilot, you're going to be using minimal instrumentation impact. You just want the plane to fly itself. And so the metaphor here is with a good address position in golf, with good, by understanding the internal forces biomechanically of the body, you want to eliminate system tension. So for example, if you have a over the top swing, creating slices, but you try to correct that by closing your stance and creating a strong grip, yeah, you might hit the ball where you'd want to, but if any one of those pieces, since they are fighting each other, is tweaked even a little bit, you're just going to kind of spiral out of equilibrium and have some really bad shots. So by using a biomechanical tool to help understand the body and how things impact each other internally, we are trying to create that Occam razor of just the simplest swing for each specific golfer. And I think another piece that would be useful, so this is just for orthodontists, a software they use. And so just from interviews with people, both students and professionals, there's this thought of, hey, I see things that need to be fixed. I can explain the why, but not how to fix it or where to start. So I'll run this video for you, but you'll see the front two incisor teeth that kind of catches your eye, like, oh, that's the flaw in the swing. But you'll see from this video, uh, they show, hey, we're going to start with the molars. We're going to create this space for the teeth, and then we're going to go to the cuspids. And if we create and eliminate all these other aspects that the eye was not drawn to, gravity can just take care of the rest with the incisors. So I think a piece that's really not addressed right now in golf instruction is showing the student more of just the micro, just showing them, hey, this is the big picture. Let's use the app, the tool, to look at hundreds of your swings. Let's see what the trends are. Here's where point A is right now. How do we get to point B? Let's walk through 5 weeks and we can simulate this. If we have a high fidelity body model and I can show you, hey, I'm just going to show you an avatar of yourself and move your left arm in here and move your hip here. Let's run a simulated swing and see how that fixes things. That can really help both sides of the golf lesson. So with that, I'll close on, hopefully you all were, again, thank you so much for being here and showing your excitement in this kind of golf. Here's a QR code if you would like to provide our team with any feedback on why you may or may not use golf apps right now with a biomechanical flavor, what works for you, what doesn't. Similarly, any frustrations or things you like about golf lessons, that'd be very appreciated. So I'll keep this up during the Q&A, but that is the conclusion of my presentation.
Great. Thank you, Ben. That was fantastic. I'm just on audio because the QR code is there. Okay, here we come. So what a fantastic presentation. While you peruse the Q&A box and think about which ones to answer, and it doesn't have to be in chronological order. I just wanted to make it clear to everyone, Joe Roca is on the webinar as well, the MIT Golf Coach and advisor to Porrig Harrington, etc., and obviously assisted Ben as well. So Joe's on. A recording of this webinar, I should have said, will be available in a couple of weeks. And also a version of the slide deck will also be available. Amy, what's the best, your email or the MITAGA email if people would like to request any of those? And can we put it in the chat? Or
Yes, I'll put it in the chat, Tony.
yeah, so to request presentation and or recording. Great. So anything pop out already, Ben or Joe, in the chat box, other than the ones about how much better your swing is now, Ben, as a result of all this research? I like that line of questioning, but
Well, we can start. So I'll just say, it's kind of a dual beneficial thing is now that we have the foundational app for alpha and beta testing, something I'm going to be working with Joe on my own swing and just kind of using that as a sandbox for what kind of metrics are beneficial to me, what kind of things are useful to him, and we can kind of work through that live to help recreate a positive feedback loop with the app. So for my swing, I am the father of two young children right now, so that is one of the greatest challenges to having time to be on the course. But so right now, I'm excited about the app and working on it. That's kind of a way for me to find a refuge to be connected to golf. But I'm not quite there with access to practicing to be where I want with my swing.
yeah, yeah. And then I thought interesting. Someone said that, and I noticed it too, that Tony Finau was a bit of an outlier on, you had the summary
Yes,
graph and all of his dots, if I remember, off or concentrated off to the left. We know he has a very
yes.
sort of truncated, looks armsy almost swing. But anyway,
Yes.
what's
So I
going
will
on with
say,
him?
Tony, if you look in the thesis, I do have a whole section on why he gave me fits with my theory on the wrist segment being between the pelvis and the front left wrist. I tried doing one where it's just left wrist to shoulder, and I think it was just that it's both the video and maybe he's just kind of a nemesis to recording. So I wasn't really happy. I'm not blaming the video itself. There's probably some flaws in my own modeling, but I don't think that was quite a accurate reflection of him. But he does have a unique swing, similar to it's compact like Rahm. There's some uniqueness to it, similar to Jim Furyk. So um, I do see a
Yeah,
question about X factor. Please redefine X factor. So this actually might be useful. So who's a I'll do Rahm. So for X factor. Quantitatively, so you see the yellow line for hips and the blue line for shoulders. The max angular distance between those is the X factor. So for again, most golfers will stop their hip rotation a little earlier, and then they'll keep rotating their upper body, and that's just maximizing that elasticity of the thorax to really create some explosive downswing velocity.
Yeah. And then the very first one in the Q&A, if you can get there, is looking at the future and
Oh,
could we
sure.
use haptics as a better guide? So it looks like an evolutionary question, if you will. Do you have the
Yes.
very first one from
Yes. Yeah.
Bruce?
So I think internal sensors are great. Like ILMs, some people put them both in the golf club themselves. Some of these expensive products like gears, they have that kind of technology for each center point. It's measuring both the XYZ axis as well as the roll, pitch, and yaw. So I think that, I think aligned with, maybe there'll be a golf chip in the golf ball soon, even though there's much more compression in a golf ball compared to every other sports ball. Having that to be able to find the golf ball, having chips so small that they can be positioned just like almost like a piece of tape on your wrist or something, where you can have a lot. That is something I didn't talk about, which is a good reminder. Is um, everyone, even professionals, they're looking at their analysis of themselves on the practice course or the practice field. But something that comes to mind for me is Shaquille O'Neal was a 50% free throw shooter in games, but allegedly a 90% free throw shooter in practice. So if we partner with a broadcasting group like NBC or CBS, and we can run that video through our tool or modeling and provide golfers with how they're performing actually on the course under pressure with mental stress, and just show them, hey, these are the times where you're failing. You had a triple bogey on this hole. What was falling apart with your swing? Or why was the whole set up in a way that didn't favor your style of golf? Like that is a new frontier that's been validated through my talk with professionals, or PGA teaching professionals on, hey, that would be a great thing to provide. So I think related to that question, there's a lot of future there with sensors and then also applying it the real competitive environment.
Yeah. And then towards the end of the list, Tim asks, could there be, or are you developing as simple as having you submit your video of your swing, and then it shows you where your swing is a standard deviation away or whatever from a solid swing, so you can kind of work out where you want to go next with your instructor.
Yes, I think that is yes and no. So I think, one of the golf apps that's available right now is it has something where it gives you a swing score. And one of the comments I was reading in for the app was, hey, I ran my swing through it and it gave me a 96, and then I ran a video of Tiger Woods and it gave him a 79. That doesn't make sense. I'm a 25 handicap. But to that point, I think it would be great to partner this with one of these high tech labs. So, for example, Padraig Harrington working with Mike Jacobs, he can travel to his lab in the United States, get some really high fidelity feedback. But then while he's on the course or while he's back in Ireland, he can send video to Michael, and Michael can either run the lesser quality smartphone video through and see if there's constant standard deviation errors or bias errors, and can kind of fuse that data with his high fidelity data, or just, hey, in between lessons, like here's 100 swings I've done. How's that stacking up to the trends we were working on at the lesson? So I think that's absolutely the right mindset to use.
And related, I think Albert's asking a question a lot of us probably were thinking. So, based on your research, if an amateur golfer could improve only one thing, what would deliver the greatest return?
Um, so I think just seeing the variation in each golfer, how I mentioned that fingerprint analogy, is if you can, and also with Jim Furyk, if even like embrace the uniqueness of your swing as long as you can build consistency with it. And so if it's kind of a cheating answer, Al, but if you can just find pieces of your swing that work consistently over time, and maybe that's something that, our future tool can help with too, is like, hey, the first third of your swing is textbook. Don't change anything there. But the middle third, that's where there's a lot of volatility. So let's, for your own personal drills, like work on figuring out why there's volatility there and stabilizing that element of your swing. That's something to focus on. So sorry, I don't have a better answer for you. Maybe next year with some app insight. But I think golf is such a beautiful game because you can create success without looking like the textbook swing.
Yeah. And Joe, I don't know whether you're able to come off unmute. Be interesting to hear your view on this whole field. You've been there, done that, seen lots of great players, seen lots of people evolve and improve? How do you put this in that world of yours and where it's all headed?
Yes, thank you. Can you hear me okay, Tony?
Yes, we can. Thanks, Joe.
Oh, no, thanks for having me. It's an honor to be here, and working with Ben has been a pleasure and really a great opportunity. Well, the variation is a sticking point, right, for us teachers, because so many different swings, as Ben said, everybody's swing is a fingerprint. That's on the one side of it. And then on the other side of it is when, Ben, you were talking about the plane. I love that analogy because that's really the basis of my teaching is to, well, you said it way better than I'm going to attempt to say it, but everything's sort of in balance, and we're not trying to correct a mistake with maybe another mistake to cancel it all out. So sometimes I get talking and kind of forget the question, but no, I think some of it is the fundamentals are still the fundamentals. I think to the question of what you can do to become better players is definitely like the old, grip and posture. Sometimes people, come to me without, a good grip or posture, and I think that's something kind of like a low-hanging fruit that everybody is capable of getting into is a solid setup position. As far as where it's going, I love the orthodontic, the visual there. I think with us teachers, sometimes we do see, depending on the player, we do see multiple things happening, and the question is really where to start. And also to, as Ben alluded to, give the student a roadmap. I think that's really key as well. I think the roadmap, like as the teeth got in line, I think giving a roadmap to students would be really, really cool, and some help with teachers as far as sort of that quote, what to fix first, and more of a sequential way of helping people with their swings. I know when I teach in the golf room next door, they teach karate. So I've enjoyed talking with them a little bit. They've been super nice to me to kind of indulge me in sort of their philosophy a little bit. And they have that nice belt system. You start at a white belt and you go up the chain, and recently they were having black belt tests. We don't necessarily really have that in golf, and I'd like to see that, evolve to where we would have more of that systematic, approach to getting people to where they want to be. One last quick thing is what I've been surprised at really teaching over the years is how realistic people are with their expectation of how good they can be. So it's kind of frustrating that we can, as a teaching community, deliver on that, request of students to just kind of inch more toward what they know instinctively they can be as a player.
Right. Good. I think I have modest aspirations, so that as well. Well, Joe, thanks very much. It is time. And Ben, thank you for a fantastic presentation and answers to Q&A and sharing what obviously was your opus magnus and a very personal and inspired endeavor in your thesis. So we really appreciate that. I thought it was fantastic. For those of you whose Qs were not answered, we'll find a way to answer as many as we can separately. So thank you very much for that. And just a final plug for future webinars and event for MITAGA. As I mentioned at the beginning, we have a senior engineer who also is a PhD from MIT, who works at Callaway Golf, coming up later this calendar year. And then Rob, who is the veteran PGA Tour management team person who is now running the Annika Foundation. So those are the next two ones to bat, to mix metaphors. And again, thank you everyone for being here. Hope you enjoy summer golf if that's the correct hemisphere for you. And again, thank you so much to both Joe and Ben for being here and all the work that went into it. So thank you very much and have a great day, everybody.